Hello boys and girls. Today we're going to be starting a new unit. I will ask you to use the ruler that I sent you. It should have arrived and you can use that to help you with the new math that we're going to work on. It won't be necessary to use every time, but whenever we're drawing some straight lines as well as measuring to break things up, I would like you to use that to help you. First off, if you would please go ahead and open up your books to page 369. You can have that open and well, we'll take a look at some things today. First off, we're going to be taking a look at what you see in numbers 1 and 2. And if you notice, there's two highlighted words. You'll see also at the top right, they're vocabulary words in this lesson. The first word is rows. Rows are what you would do whenever you had a horizontal line with your arms spread across from left to right. You need to know the difference between rows and the next word, columns. So I'm going to ask you to take a look at each of these, and even though the pictures are exactly the same, the rows and columns are different. So what I'm going to do here is I'm going to take my pen and I'm going to go across the rows. So there's one row here. It goes all the way from this side to this side. Doesn't matter how many squares are in there. There's one row there. And if you look, there's a second row here. Now the deal is, in the pictures we're working with, the rows have to be the same length. You can't have one shorter or longer than the other. So this one is as long as this one. There are two rows. So I would simply understand that, yes, there are two rows here. Well, how many is in this row? Yep, there's 5. How many are in this row? 5. I'm going to write down that number here and here. So I remember there's 5 in this row and 5 in this row. I don't have to count again. Well, let's look at that same picture because there's a second way to move. Columns. That is going vertically, up and down. So as we are taking a look at the columns, this one has 1 column, 2 columns, 3 columns, 4 columns, 5 columns. Now each column is exactly the same length. They are going to be equal. There are none that are going to be longer or shorter than others. So how many are in this column? 2, you're right. And since they're all the same, there has to be 2 in each of these. 1, 2, 1, 2, 1, 2, 1, 2. All right, so boys and girls, we're taking a look at rows and columns. So this is important that you really have this established. Notice I've written down how many are in each row over here and how many are in each column over here. That's going to be useful for the next word we're going to take a look at in the next part. So let me check off rows and columns. All right, boys and girls. Now, if you remember from the video that you had just watched on arrays prior to starting mine, we are going to be talking about arrays. Arrays can be like what you see at the top of our page, but I'm going to tell you, they don't always have to be a square to be an array. An array is an arrangement of equal rows and equal columns. So arrays can look like this one in number 3. Yes, they're pairs. I get it. They're totally something not like squares. But they're still equal. This is the same and this is the same as this. So what I would do is I want to be able to make sure I understand that they're equal. Notice there's some lines to the side. I'd like you to write down how many pairs are in this first row. Did I hear you say 2? Let me check. 1, 2. Absolutely. And there's 2 in this row and 2 in this row. That means there's 1, 2, 3 rows of 2. Now let's go down the columns. There are not 2 in this column, but 3. And this one has to be equal as well. So again, it's 3. Okay. Well, let's go over to this next one over here, and then we're going to come back and talk a little bit more about the numbers we've written down and how we can use them to make equations. For example, in this one, this is an array of stars. There are how many in this first row? That's right, there's 4. Because it is an array, it has to have an equal number in this row, again, 4. I can tell you looking at this first column, that's not 4. How many is it? You're right. There's 2 in each one of these columns. So now what, Mr. Fredericks? I can easily count those rows and columns. What should I do next? Well, I want you to use those to make 2 equations. Let's focus over here on this first one. Let me bring down my shade so that you and I can focus just on number 3. So I'm going to take the numbers here at the bottom, the 3 and the 3. When I'm talking about the whole picture, I'm taking 3 in this column and 3 in this column, and I'm adding them together. And that will give me a total, of course, of, yeah, that's right, 6. These are easy numbers by now at this point in the year. But you can have a second equation, and that happens to do with the rows. So I'm going to go to the numbers over here. I'm going to take my 2, I'm going to add in my next row of 2, and the last row of 2, and that gets me a total of, that's right, 6. So in this array, we have 2 equations we can create. 3 plus 3 equals 6, and 2 plus 2 plus 2 equals 6. Notice the add-ins in each equation are the same number repeated. Arrays are often called repeated addition. That's because you use the same number and add it again at least twice or more to get your total found in the array. This is going to be the very beginnings and the start of what you'll use to help you understand multiplication. But don't worry, we're not there today. Let's take a look at the next one. Since I had a column of 2, 2, 2, and 2, what would be the first equation using those 2's, and what would it equal? Let me help you out. I'm going to help you so much here. Ready? I'm going to put in the equal sign. What? That wasn't very helpful? Please go ahead and give it a try. I have this 2, this 2, this 2, and this 2. What equation will we write that would be on this side, and what would the total be on the other side? That's right. 2 plus 2 plus 2 plus 2. I'm taking each column and adding it together, which gives me a total of, let me think. I know 2 plus 2 is 4. Wait, there's another 2 plus 2. That's 4. Then I can take my 4 plus 4 equals 8. You're right. Those doubles facts really come in handy when working with arrays. Since I've used the 2's, I now need to come up with another equation that uses the 4's. Let me be really super helpful to you today. I'm going to put it in the equal sign. What was that, Audrey? That wasn't very helpful? I think you're right. What would the equation be using the 4's? Bella, did I just hear you say 4 plus 4? You're right. What would that equal, everybody? You got it, 8. So again, an array is a picture using rows and columns that could be of squares or any other object. And that shows us the total number within a repeated addition. 2 different repeated addition equations can be created from any array. Let's move on to the next page and take a look at some more when it comes to arrays. Oops. Let's move on. The very next page. So boys and girls, taking a look at page 370 now, I've got some rectangles. Now, these rectangles in your books don't have the lines. What I'd like you to do, with the best that you can, using the ruler I provided you, make your rectangles look like this. Please go ahead and pause the video to help you do your best. Now, there is one trick. You've got to do your best to make them look like the squares you see here, because in an array, everything is the same and needs to be equal to every other part. Please go ahead and pause the video, and when you're done, start it up again. Hey, welcome back. I know that probably wasn't the easiest. I know it takes some practice too. So let's take a look at what we're doing. Whenever we take a whole object, like a rectangle, I don't know, the rectangle to me, and when I break it into pieces, reminds me of a chocolate Hershey's bar, of course. If you've looked at a Hershey's bar, it's already kind of set up like an array because they have pieces that are kind of printed in the bar itself to make each part break up into something that looks like another piece, just like it. We call this partitioning. A partition, if you look at this word at the top, partition, has the word part in it. But in a partition, every part is the same as the other parts. There's no bigger or smaller part. Also, when you partition with rectangles, you will have an array when you're done. Check it out. Here's a row. Here's another row. And look at this. Here's a column, a second column, a third column, and a fourth column. Now, I know it says write the number of small squares. And absolutely, you could count them one at a time. But would anybody out there like a faster way when it comes to more squares to count? Thought so. Well, for all of you that would like that quicker way, we're going to use what we just learned about rows and columns, writing those numbers down to help us make an equation that will help us quickly get to the answer instead of counting by ones. Now, I know some of you have already counted it by ones and have the answer for number 5 down. That's great, but you should still learn it because when we get to bigger arrays with more partitions, you're not going to want to count each one individually. It takes too long. So let me just go here to this column. I see there's 2, 2, 2, and 2. If I now use what I learned and add them together, 2 plus 2 is 4. 2 plus 2 is 4. And 4 plus 4 is 8. There's 8 squares. Now, for my friends who say the words that I always say in math class, prove it? I'll prove it to you. But I will not count by ones. I will count by twos. 2, 4, 6, 8. So keep in mind, boys and girls, we can use that for much quicker counting. Now, if I look at this one, I can see, yes, there are 2 columns and 1, 2, 3 rows. You betcha! Threes! Threes! Sure, I'll write 3 up here. And 3. And hey, since there's only 2 of them, I already know this fact. I can tell you how many squares there are. 3 plus 3 is, that's right, 6. There are 6 squares. Now, some people are good at counting by threes. Others might not be. And if you're not good at counting by threes or know your 3 plus 3 fact yet, you could go another way. You could use the number of squares found in each row. And I will use this equation, and I'll get the exact same answer. 2 plus 2 plus 2 equals, that's right, 6. So boys and girls, you can use what we learned to help you find the answer for how many small squares there are in these partitioned rectangles. It's going to come in handy when you come down to here, because I am not counting by ones to do this. So I am going to go ahead and I'm going to find another way. Well, I have, Mr. Fredericks made a mistake. Let's fix that up. I have 4, 4, and 4. Now, if I think of this as an array with an equation of 4 plus 4 plus 4, it helps me come to the answer. I know 4 plus 4, that's 8. And 4 more, what was that? You're right, it's 12. Now, for those of you that have a hard time going that way, you could go using the rows across if you prefer. I'm going to go over here and I'm going to see that, well, this one is a very large one. Let me try it this way. I'm going to go like this. 4 plus 4 plus 4 plus 4. there's 4 in each column. I'm not the best at 4s once I get past 12. Oh, well, I'm going to have to find a way because there's also 4 in the columns as well as 4 in the rows. All right, here we go. 4 plus 4 is 8. 4 plus 4 is 8. Oh, 8 plus 8 equals 16. Now, for those of you that want to count by ones, I'll show and prove it to you by ones as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It just takes a lot longer. And the more partitions there are in a shape, the more you'd have to count. There's got to be a quicker way. Well, friends, I already told you counting by threes is not my best strength anyway in counting. So I see there's a row of 3, 3, 3, 3, and 3. I can't do that without making too many mistakes. Let me try the columns. There's 5. Ooh, I'm really good with 5s. And since there's 3 5s, I already know 5 plus 5 is 10. And using my make 10, whenever I add to a 10, I know it's going to be that 1 in the 10s and that second number in the 1s. So I already know it's 15, which means I have 15 squares. Let me prove to you we count by 5s. 5, 10, 15. So friends, we can use this information to help us when trying to find the number of squares partitioned inside a shape. Let's take a look at something else here with me, please. You'll notice that I have some rows and columns of rectangles. Now, I certainly could count this up, but that's not what I'm here to do at this point in time. What I want to do now is I want you to see that I can cut this into equal parts. Check it out. I'm going to go ahead and cut. That's right. I'm going to cut it up into equal shares, meaning there's going to be a same for a part for each one. So I'm going to cut this up, then I'm going to cut it into this piece and this piece. So this share has 6 and this share has 6. That means I have 2 groups of 6. Whenever I cut something into 2 equal parts, it has a special name. Do you know what it is? You're right. It's called halves. If you've ever taken an apple and cut it into 2 equal pieces, you made halves. If you've ever taken a chocolate Hershey's bar and broken it into 2 equal pieces, it's halves. Notice I keep using the word equal because anytime I have half, each part has to be equal to the other part to make it fair. I want you to take a look at this one. Is this showing halves? Well, let me see. I'll circle this part and this part. Well, there's 2 parts, but I can't say it's halves until I make sure each part is equal. How many are in this one? That's right, there's 6. How many are in this one? That's right, there's 6. This does show halves. Well, let's take a look and understand a little bit more about 2 equal shares, also known as halves. So, friends, if you look at what we had from the other page, we had 2 different ways using the same squares to show 2 equal shares. Let's check out this one. If you look at this one, is this share the same as this share? Because I see there's 2 of them, the orange ones and the purple ones. You're right, they are. How many are in the half that's orange? Don't count by ones. You find a faster way? 4 plus 4 is 8, and 4 more is 12. Let me check this. 4 plus 4 is 8, plus 4 more is 12. It's the same. Hey, if we went back to this rectangle and tried to make it show equal halves again, it could look like this. But friends, this is no longer halves because I don't have 1 part and 2 parts. I have 4 parts. Yep, 4 parts. Check it out. I have a part here, a part here, a part here, and a part here. 4 parts. Now I know some of you are going to say, but there's this part and this part are orange. That doesn't mean anything. They are not together. Over here, all the orange were in one part, and all the purple were in a part. Here we have 1 part orange, a 2nd part purple, a 3rd part orange, and a 4th part purple. They're all equal in their shares as well. How do I know? Well, because each one has exactly 1 column of 1, 2, 3, 4, 5, 6. 6, 6, 6, and 6. This is what we call force. Now I'm going to uncover this last one to show thirds. Thirds is often the trickiest to show because it's not something we're used to thinking. We're used to thinking of breaking things into halves for 2, or maybe into fourths for 4. But thirds doesn't usually happen very often and isn't what we expect or is easy for our mind to understand. So check out this one. If I have 1 part, a 2nd part, and a 3rd part, and each part is equal in its shares, I have shown thirds. So I see there's 1, 2 columns of 6. 6 plus 6 is, that's right, 12. Let's check out this one. 6 plus 6 is 12. This one's got to have 12 if it's going to be another third. 6 plus 6 is 12. So boys and girls, if you'll go ahead and turn to page 371 with me, I'd like you to go ahead and try your best, get help if you need to make your rectangles have the lines to partition in the same way as you see here. Please pause the video and come back when you're ready to do the next step. Hey, welcome back. All right, we're going to do some shading. So I'll tell you what, it doesn't have to be pencil. If you want to use a crayon or colored pencil, you go for it. I'm going to say no markers because as you already know from all year long, the paper in your math book, markers bleed through and it just doesn't work real well. So I'm going to go and pick one of my colors here. Oh, I'm going to pick my blue one. So what we're going to do in this activity is we're going to shade to show halves, thirds, and fourths. So halves, remember, is 2. Go ahead and put 2 above there. Thirds, remember, is 3. And fourths, remember, is, that's right, 4. So I have to have a share that is like all other shares, but the number of shares is going to change depending on what I'm doing. So halves. So I want to take this big rectangle and cut it in half. Right through the middle. So I'm going to go ahead and color in this one, this one, this one, this one, this one, and this one. I have 2, 4, 6 that have been shaded. I will not shade the other part. 2, 4, 6. I have the same on that one. This is called halves. Thirds for the same rectangle with those lines. How will I do that? Well, I can't color in those 6. Maybe I should try to make some columns. I'm going to do 1, 2, 3, 4. Here's 1 column. Now let's see. I'm going to switch to another color. Grab another color yourself. All right. I'm going to color this one. If this is going to be the same, I need to do 4. 1, 2, 3, 4. Go ahead and grab one more color. I'm going to grab my black one. 1, 2, 3, 4. Now, if I have thirds, I have 3 equal shares. This one's 4, this one's 4, and that one's 4. So they're all equal, but do I have 3 of them? Let me check. 1, 2, 3. Yeah, I have 1 equal share in blue, 1 equal share in purple, and 1 equal share in black. All right, well, let's go to this next one. Fourths. Remember, it's 4 equal parts. Let's see. Well, I can't go this way because I'd only have 3 equal parts like I did there. Any thoughts? Well, if I can't use my rows, maybe I need to do columns. Let me try 1 column. There it is. How many is that? 1, 2, 3. All right, switch to another color. And we have to draw how many to be equal to this one? That's right, 3. And I always go with my rows or columns. I don't jump all around. All right, so this one is 3 and this one is 3, but that's only 2. So I need to try another one. Let me try this one. Here it is. 1, 2, 3. So 3, 3, and 3. Let me try one more. 1, 2, 3. Let's see. 3, 3, 3, and 3. But are they the same? Let me see if I have 4 parts. 1, 2, 3, 4. Yeah, I have 4s. I have 1/4 blue, 1/4 green, 1/4 red, and 1/4 purple. This is a way to use rectangles and their partitions to show fourths. So, what I'd like you to do now is take what we've learned and try to do some with little differences. So next part, I want you to shade to show halves 2 different ways. Whatever you choose, I want you to choose one color to use for shading half on this one. I'm going to go with red. Let's see. If I do this, is that half? Well, let's see. I got one part here that's not shaded red and one part that is. Are they equal shares? You're right, they're not. However, I see this one has 4 and this one has more. So how do I make it so they're equal? I'm going to have to go down another column. So I have one column of 4 red, a second column of 4 red. So 4 plus 4 is 8. So for my part, I didn't shade it all. I need to have 8 too. 4 and 4 is 8. This shows half. Half of this was shaded, half is not. All right, keep that same color now, but we're going to do it a different way. So I can't have 2 columns. And by the way, coloring on this side is the same thing. It's just moving the shaded part to the right instead of the left. So if we can't use columns, we're going to have to go with, that's right, rows. Well, let me color in a row. Here we go. 1, 2, 3, 4. All right, I colored in a row. So here's one part and here's the second part not shaded. Are they equal? No, they're not the same. So let me color in another one. 1, 2, 3, 4. So I have 1 row of 4, 2 rows of 4 that have been shaded. The unshaded part, is it equal? Yes, it is. 4, 8. So I have half shaded and half unshaded. 2 different ways to show halves. Please keep in mind, we need to use whole rows and whole columns to help us show equal shares. All right, well, I'm going to switch colors. Please switch to a different color yourself. You use this color for both of these in number 14. We're going to shade to show force 2 different ways. Force? Yeah, force. All right, let's see. I'll go with a column. So I have one part that's green. All right. Let's grab another color. To keep it equal, I'm going to make another column. Now I'm trying to show force. So I have 1 part green, 1 part blue. And they each have 4. And then I have 8 unshaded. Is this force yet? You're right, it's not. All right, grab a third color. I'm going to go with red. I'm going to color in another one. And I'm doing my whole column. All right, let's see. Do I have force? Let's see. I have 4 green, 4 blue, 4 red, and 4 not shaded at all. Yeah, it does show it, even though I didn't shade this one. Tell you what, I'm going to shade my last column in with a different color. You do the same thing. All right, I'm going to go back to my green. Go back to your first color. Now, I can't just put green in this column. That's showing the same thing. So if I can't use my columns, I'm going to have to go with my, that's right, my rows. All right, I'm going to fill in a row. Here's one row shaded in green. So I've got a green row and then 3 rows of white. Is that showing force? No, it's not. All right, I'm going to go back to my blue, find your second color again, and I'm going to shade it in a second row blue. Now let's see. I have 4 green, 4 blue, and 8 white. Is that force? No, it's not, because they're not all equal shares. And I need 4 of them to be equal or the same as each other. All right, I'll go back to my third color, red. I'll color in another row of 4. Cool. All right, let's check it out. Now do we have force? Let's see, I have 4 green, 4 blue, 4 red, 4 white. Yeah, it shows force. Now, I want to color my last one with the same color I did last time. If you'd like, you can as well. All right. Now, we're going to go and try one more time. I want you this time to take a look at it. Let's shade this in half. See, half. No, I'm going to do this one. Is this half? Yeah. All right. If I go down here, it's showing the same thing. So what's another way to do it? Did you just say columns? Oh, okay. I'll fill in a column. Is that half? No. There's more white than there are purple. Let me try another column. Is that half? Yes. There's 4 purple and 4 white. Remember, you fill a whole column or a whole row. All right, friends. I'm going to tell you right now on page 372, we're going to cross off a little something here. Ready? We're going to get rid of this at the bottom. We're also going to get rid of number 16, number 17, and, well, number 18. What I'd like you to quickly do is figure out how many small squares there are on number 19, 20, and 21. Pause the video and come back to find your answer. Welcome back. So there are 9. How do I know? Because there's 3, 3, and 3. 3 plus 3 plus 3 in that repeated addition equation for this array is 9. This one is 6. How do I know? Because I have 2, 2, and 2, and when I add 2 plus 2 plus 2, it gives me 6. Over here in this one, I have 15. How do I know? Well, I have 5, 5, 5, and 5. So I'm going to add 5 plus 5 plus 5 plus 5, which, whoa, that isn't 15, Mr. Fredericks. It's what, everybody? That's right. It's 20. Even Mr. Fredericks makes mistakes sometimes. All right, friends. Now that you've finished, I'd like you to go ahead onto your activity today. Go ahead and answer your questions in the form and submit it when you're finished.